Okay, so have you ever felt like, all your digital storage, it's just kind of a mess?
Yeah, a tangled mess. It's a common problem, especially with the sheer amount of data that we're all dealing with these days.
Right, like it just keeps growing and growing. Efficient access and management, it can feel like a constant struggle.
It's like a digital mountain.
Exactly. So today we're going to do a deep dive into something that's been helping organizations kind of get a grip on all this data for over 2 decades now.
Hmm.
We're talking about the storage area network, or as it's more commonly known, the SAN.
Oh, yeah, the SAN.
Yeah, it's a pretty fascinating solution.
It is, and I think this deep dive will be really helpful to kind of demystify, what a SAN is, how it works, and why it's so important to so many organizations.
Right, and this isn't just for the hardcore techies out there.
No, not at all.
Understanding SANs, it gives you a really good look at how data is managed and accessed, especially, at a larger scale,
That's right.
which is, something that impacts all of us in the digital world. And you might be surprised to learn how specialized these networks are. They work totally differently than the kind of storage solutions you might use at home or in a small office.
Absolutely. Dedicated infrastructure, dedicated protocols, it's a whole different ballgame.
Yeah. And we're really lucky today to have, some serious technical expertise with us to guide us through all of this.
Well, I've been working with SANs for over 2 decades, helping organizations figure out how to leverage this technology. I've seen firsthand how much of a difference a well-designed SAN can make.
So just to give our listeners a bit of a roadmap, we're going to start with the basic definition of a SAN.
The foundation,
Exactly. And then we'll sort of take a trip back in time, look at how storage has evolved.
the history of storage, always an exciting topic.
Right. And then we'll really get into the nitty-gritty. We'll break down those essential hardware and software components.
We'll look under the hood.
Exactly. Then we'll talk about the protocols that make everything work.
The network languages, so to speak.
Exactly. And then we'll even touch on some more advanced stuff like storage virtualization and quality of service.
The really interesting stuff.
Yeah. Okay, so let's start with the
The
basics.
foundation.
When we talk about a SAN, what exactly are we talking about?
So a SAN, storage area network, it's a specialized high-speed network.
Okay.
And it's dedicated to one thing, giving servers access to a whole bunch of storage. But the key here is that this storage is accessed at the block level.
Okay, so block level, that means instead of dealing with, files and folders like we usually do, the server sees the storage as these little chunks, these blocks.
Exactly. It's like the raw building blocks of data. And there are some real advantages to working at that level.
So what are those advantages?
Well, for one, it's incredibly efficient, especially for applications that need a lot of performance. And by operating at that block level, it gives you a lot of flexibility. The server's operating system, it can take those blocks and format them, manage them with its own file system, just like it was a local hard drive.
Okay, so the server sees it as its own local hard drive.
Pretty much. And another crucial point, a SAN is almost always its own separate network. It's not your regular local area network, your LAN.
So it's a dedicated network, kind of like its own private highway for storage data.
Exactly. That separation, it's really key to getting that high performance and low latency that SANs are known for.
So it's not just another way to share files on the network like with network attached storage, which is what most people are probably more familiar with.
Right, NAS, it's not like that. Now you can definitely build file systems on top of a SAN.
Okay.
We call those shared disk file systems, and that lets multiple users or servers access and share those files.
So it's like building a system of roads and traffic management on top of that dedicated highway we were talking about.
That's a great analogy. And SAN technology's come a long way. We're seeing what we call hybrid SANs now.
Hybrid SANs, okay?
Yeah, they can handle both, the traditional block storage and the newer object storage, which is what a lot of cloud-based applications use.
So they're kind of bridging the gap between the old and the new.
Exactly.
Okay, so we've got this dedicated network, but how did we even get to a point where we needed something like this? What did data storage look like before SANs came along?
Well, to really understand why SANs are so important, we need to take a little trip back in time.
Okay, back in time.
In the beginning, we had direct attached storage, or DAS. It was a simpler time. You just had storage devices like individual hard drives or maybe small arrays directly connected to a server.
So each server had its own little personal storage locker.
Exactly. And that worked fine for smaller operations.
Okay.
But DAS had its problems, big problems. For one, if that server went down, you were out of luck. The data was inaccessible.
Oh, so a single point of failure.
A big one. And another thing, if you needed to back up the data, you often had to move it over the local area network, the LAN,
Oh, no.
and that could really slow things down, especially as the amount of data started to grow.
Yeah, talk about a bottleneck.
Exactly. So the industry started looking for solutions. They came up with direct attached shared storage where multiple servers could share the same storage,
Okay.
but that created its own problems, managing all those servers, trying to access the same storage, preventing them from corrupting the data. It was tricky. Then came network attached storage, NAS.
Okay, yeah, NAS. I've heard of that.
Yeah, so with NAS, you have dedicated file servers plugged into your LAN, which makes sharing files much easier.
Okay.
But there was still that problem of backups and large data transfers relying on the LAN. Can you imagine moving like terabytes of video files over your office network?
Oh, that would be a nightmare.
A total nightmare. It would just bring everything to a standstill.
So SANS came along to solve this problem.
Precisely. We recognized this bottleneck early on at Stonefly, and we really pioneered solutions that created this dedicated storage network, and that bypasses the LAN completely.
Okay, so the SAN takes all that heavy traffic off the main road and puts it on its own express lane.
Exactly. And while NAS, it uses those standard network protocols like TCP, IP over Ethernet for everything, SANs use specialized high-performance protocols,
Like what?
like Fibre Channel and iSCSI, InfiniBand. These are all about speed and efficiency.
Okay, so it's like comparing a regular car to a race car. They both get you from point A to point B, but one is just built for pure speed.
That's a great way to put it. And this is why SANs often need their own specific hardware, their own switches, their own storage devices. It's a bigger investment than NAS. But for organizations that need to move lots of data quickly and reliably, those benefits are often worth it. At Stonefly, we've been doing this for over 2 decades. We know how to design a SAM that's both cost-effective and super efficient. If you're curious about how we do it, you can visit stonefly.com or reach out to us at sales@stonefly.com.
Yeah, I mean, it's clear why SANs are so popular in certain industries. Okay, so we've talked about what a SAN is and why it exists.
The what and the why.
Right, but what about the how? What actually goes into building a SAN?
Well, you can think of a SAN in terms of 3 layers: the host layer, the fabric layer, and the storage layer.
Okay, let's break those down. Let's start with the host layer. Who are the hosts in this scenario?
The hosts are the servers, the ones that need to access all that data on the SAN. But these servers, they need special hardware to talk to the SAN.
Okay.
We call those host adapters. And the most common type is the Fibre Channel HBA. It's like a network card, but specifically for storage traffic. It plugs right into the server's motherboard.
So it's not just your average everyday network card.
No, it's built for speed. It's got its own firmware, special drivers. It's all about fast, reliable communication with the storage. And in a Fibre Channel SAN, these HBAs connect to the SAN fabric through these things called GBICs, Gigabit Interface Converters.
GBICs.
Yeah, and those are on the SAN switches and storage devices, too. They convert those digital signals to light pulses.
Okay.
So the data can travel over fiber optic cables.
Right, light speed.
Exactly.
Okay, that's the host side. What about the fabric layer? That sounds like the actual network itself.
It is the network, the heart of the SAN. It's all the networking gear: switches, routers, bridges, gateways, and of course all the cables that connect everything together.
So it's like the infrastructure, the backbone of the whole thing.
Exactly. And early SANs used to use these things called hubs.
Hubs, okay.
But now pretty much everyone uses switches, Fibre Channel switches. To be precise, they're way more efficient.
So what's the difference?
Well, a hub, it's like a big party line. Everyone shares the same connection.
A switch, it creates dedicated pathways between devices. So multiple devices can talk at the same time without stepping on each other's toes.
So much less congestion.
Exactly. And in modern SANs, we mostly use fiber optic cables for the connections. You know, those cables made of glass fibers that transmit data as light. They're super fast and they can go really long distances.
Okay.
And redundancy is super important in the fabric layer.
Redundancy, so backup systems, right?
Yeah. You want multiple paths between devices, so if one connection goes down, the data can still get through.
Makes sense.
So you'll often see SAN switches connected in a mesh topology, kind of like a web.
Okay.
And these switches, they come in different sizes. You have small switches with just a few ports, then you have bigger ones with dozens of ports, and then there are these huge director-class switches that can handle hundreds of connections.
Wow, so it's scalable. Oh yeah, very scalable. You can start small and grow as your needs grow. And the communication within the SAN, it follows this protocol called FCSW6, the Fibre Channel Switched Fabric Protocol. And a key part of that protocol is this concept of WWNs, worldwide names.
WWNs.
Yep. Every device in the SAN, it has a unique WWN. It's like a serial number, but for SAN devices. It's hard-coded into the hardware, so it never changes. And when a device connects to the network, its WWN is registered with the SAN switch, so everyone knows who's who.
Okay.
Storage vendors, they also use these things called WWPNs, worldwide port names, and WWNs, worldwide node names.
So more names.
More names, but they're all about identifying specific ports and devices within the SAN. And you can actually tell a lot about a device just by looking at the first few digits of its WWN. For example, storage port WWNs, they often start with the number 5.
Okay.
And super bus adapter WWNs, they might start with 10 or 21.
Interesting.
Yeah, it's a lot of detail, but that's what we do at Stonefly. We've been designing and deploying these complex SAN fabrics for over 2 decades.
Okay, so we've got the host, we've got the fabric. What about the last layer, the storage layer?
The storage layer where all the data lives.
Okay.
This layer includes all different storage devices connected to the SAN. You've got your high-performance disk arrays. Those are like the Ferraris of storage. Then you have JBODs, which is just a bunch of disks, usually without any fancy RAID protection. And then you have tape libraries, which are, the old, reliable for archiving data.
Okay.
In the SAN disk arrays, they often use RAID, redundant array of independent disks.
RAID, yeah.
It combines multiple physical disks into a single logical unit. It gives you better performance, better protection against disk failures, or sometimes both.
Right, makes sense.
And to keep track of all those devices and storage partitions, we use N's, logical unit numbers.
UNS, okay.
Yeah. Think of an N as a unique address for a chunk of storage. Any device in the SAN that's authorized can access storage using that LN. It's like a room number in a giant data hotel. And LUNs, they're really important for controlling who can access what data. You can set it up so that only specific servers can see specific LUNs.
So it's about security and keeping things organized.
Exactly. And there are a couple of ways to do that. There's LN masking, which is done on the server side.
Okay.
It basically hides certain LUNs from the server so it doesn't even know they exist. And then there's zoning, which is done on the network side.
Okay, zoning.
Yeah. You divide the SAN into these zones, and devices in one zone can only talk to other devices in the same zone. It's like putting up virtual fences within the SAN.
Right, to keep things separate and secure.
Exactly. So you have the host layer, the fabric layer, and the storage layer all working together. And that's what makes a SAN such a powerful and flexible storage solution. And at Stonefly, we've been architecting these intricate systems for over 2 decades, tailoring them to meet the unique needs of each of our customers.
Okay, so we've got all these different layers, but they need to communicate somehow. And you mentioned earlier that SANs use these specialized protocols.
Yes, the protocols are crucial. They're like the languages that allow everything to talk to each other.
Right.
And there's a whole mapping layer that allows different protocols to work over the SAN infrastructure. So one of the most common protocols is FCP, Fibre Channel Protocol.
FCP.
Yeah, and it basically takes those SCSI commands, which are used for direct attached storage, and it encapsulates them so they can travel over the fiber channel network.
Okay.
Another big one is iSCSI, Internet Small Computer Systems Interface, and it does a similar thing, mapping SCSI commands but over TCP/IP.
Which is the protocol used on the internet, right?
Exactly, and that means you can sometimes leverage existing Ethernet networks for your SAN, although a dedicated network is usually better for performance. Then you have other protocols like FCOE, Fibre Channel over Ethernet.
FCOE.
Yeah, it tries to combine Ethernet and fiber channel traffic on the same network. And ISER, iSCSI extensions for RDMA, which is all about improving iSCSI performance by using this thing called remote direct memory access.
Okay, getting technical here.
And then you have SRP, SCSI, RDMA protocol, which is another way to implement SCSI, but specifically designed for RDMA. And we can't forget about SAS and SATA. They're often used to connect storage devices within a smaller subsystem, kind of like a mini SAN within the SAN. And they can be networked using SAS expanders.
Okay.
At Stonefly, we've been working with all these different protocols for over 2 decades.
Okay.
We understand how to get the best out of each one, depending on your specific needs.
So it sounds like choosing the right protocol is pretty important.
It can be, yeah. It depends on your performance requirements, your budget, your existing infrastructure. And if you're not sure where to start, we're always here to help. You can visit stonefly.com or contact us at sales@stonefly.com.
All right, so we've talked a lot about the hardware, but what about the software side of a SAN? I mean, it can't all be just cables and boxes, right?
Absolutely not. A SAN needs brains. It needs software to manage all that complexity. The Storage Networking Industry Association, or SNIA, they define a SAN as A network whose primary purpose is the transfer of data between computer systems and storage elements.
Okay.
But they also make it clear that you need a robust software layer to make it all work.
Right, so it's not just about the physical connections, it's about how you manage and organize everything.
Exactly. With a SAN, storage is pooled together. It's not directly owned by any one server. And that's where SAN software comes in. It manages that shared resource, makes sure everything is running smoothly.
Okay.
And one of the key things it does is it lets storage devices talk to each other directly,
Okay.
for things like backups, data replication, that kind of stuff. And that takes a lot of the load off the servers.
Right, so it's more efficient.
Much more efficient. Now, there are two main ways to manage a SAN: in-band management and out-of-band management.
Okay, what's the difference?
Well, in-band management, the management traffic, it travels over the same network as the storage data.
Okay.
Out-of-band, it uses dedicated separate connections.
So it's like having a separate control room.
Exactly. And this SAN management software, it collects tons of data from the storage devices, read and write speeds, latency, errors, how much space is being used, if any devices are having problems.
So it's monitoring everything.
Constantly monitoring. And it often uses SNMP, the Simple Network Management Protocol.
SNMP?
Yeah, to send alerts if anything goes wrong. And back in 1999, they came up with this open standard called CIM, the Common Information Model.
CIM, okay.
It was all about creating a unified way to manage storage devices from different vendors.
Right, because everyone has their own proprietary system.
Exactly. And then came WBEM, Web-Based Enterprise Management.
WBEM?
It's like the web-based evolution of CIM. It defines these standardized objects that represent storage devices.
Okay.
And the cool thing is you can manage these objects using a CIM object manager, or CMOM.
CMOM.
Yeah, and that gives you a much more centralized approach to SAN management. And for basic device management, there's SMIS, the Storage Management Interface Specification. It's basically a directory where all these CIM objects are registered.
Okay.
So other management applications can easily find them and interact with them.
Right.
Of course, each storage vendor also has its own software for managing its own devices. That's where you set up things like zones and LUNs. But one of the biggest challenges in the SAN world is managing environments with devices from multiple vendors.
Right, because they don't always play nice together.
They don't. To get true unified management, you need those vendors to open up their APIs to each other.
APIs, application programming interfaces.
Right, so that a higher level management system can control everything. And at Stonefly, that's something we've been focused on for over 2 decades. We're experts at integrating and managing multi-vendor storage environments.
Okay.
We make sure our customers can get the most out of their infrastructure, no matter what hardware they're using. You can learn more about our approach to SAN software and management at stonefly.com. Or you can reach out to our sales team at sales@stonefly.com. We're always happy to chat.
Yeah, it's clear that managing a SAN, it's a pretty involved process.
It is. It's not a set it and forget it kind of thing.
Right. Now, you've talked about SANs operating at the block level, but how does that actually relate to file systems? The way we organize our files and folders on our computers.
That's a good question. So a SAN, it gives you the raw storage capacity, the building blocks of data, but it doesn't impose any structure on top of that.
Okay.
It's up to the server's operating system to take those blocks and create a file system, to organize them into files and folders.
Right, so the server sees those LNs we talked about as local disks, and it just formats them and creates its own file system on top of that.
Exactly. And if you only have one server accessing a LN, that works great.
Okay.
But if you have multiple servers all trying to write to the same L and N at the same time, without any coordination, you're going to have problems.
Yeah, data corruption. Right.
Big time. So to share data at the file level on a SAN, you need a special kind of file system.
Okay.
We call it a shared disk file system. It's designed to handle multiple servers accessing the same storage safely. It has built-in mechanisms to prevent conflicts and keep the data consistent.
So it's like adding a traffic cop to that busy intersection.
Exactly. The shared disk file system, it brings order to the chaos.
Okay, that makes sense. You mentioned earlier that the media and entertainment industry is a big user of SANs.
Oh yeah, they love SAMs.
So why is that?
Well, they deal with massive amounts of data, huge video files, and they need to move that data around incredibly fast.
Right. Low latency is key for them.
Absolutely. And SANs are perfect for that. In fact, in some high-end video editing environments, they even talk about serverless SANs.
Serverless SANs, okay.
Yeah, the idea is that the video workstations connect directly to the SAN, so there's no bottleneck created by a file server in the middle.
So it's like cutting out the middleman.
Exactly. And they often use these things called distributed file systems to manage all that data, to make sure everyone can access what they need when they need it.
Okay.
And another really important thing in these high bandwidth environments is quality of service, or QoS.
QoS.
Yeah, it lets you prioritize traffic so the most critical applications get the bandwidth they need, even when the network is busy.
So it's like having a VIP lane on the highway.
That's a great analogy.
Okay, so can you tell us a little bit more about QoS in the context of a SAN? What exactly does it involve?
Yeah, so QoS and a SAN, it's all about making sure that everyone gets the storage performance they need.
Okay.
It's about setting and enforcing service level agreements. And there are a few key things that we manage with QoS. Bandwidth, how much data can be transferred per second,
Great, we've talked about that.
latency, the delay between a request and a response. And then there's queue depth. That's the number of I/O operations that are waiting to be processed by the storage devices.
Okay.
And sometimes people think they can just solve performance problems by over-provisioning, buying way more storage and bandwidth than they need.
Right, just in case.
Yeah, but the problem with that is if the traffic patterns are unpredictable, you can still hit those limits, and then performance for everyone suffers.
Right, so it's not a foolproof solution.
Not at all. At Stonefly, we've been designing SANs for over 20 years, and we understand how critical QoS is.
Okay.
Our solutions give you granular control over all those performance factors.
Okay.
So you can make sure your most important applications always have the resources they need. If you're dealing with demanding workloads and you want to learn more about our QoS capabilities, visit stonefly.com or contact us at sales@stonefly.com.
Okay, we've covered a lot today, but there's one more thing I want to touch on before we wrap up, and that's storage virtualization. Can you explain what that is and how it fits into the SAN world?
Sure. So storage virtualization, it's all about creating this abstraction layer between the logical storage that users and applications see and the actual physical storage hardware.
Okay.
Basically, you take all your physical storage, all your different disk arrays, even if they're from different vendors, and you pool them together.
So it's like creating a giant virtual storage pool out of all those separate devices.
Exactly. And then from that pool, you can carve out logical storage units like volumes and LUNs and assign them to your applications.
Okay.
And one of the big advantages here is location transparency. The users, they don't need to know where their data is physically stored.
Right.
The virtualization layer takes care of that. It maps those logical requests to the right physical resources.
So it's like having a virtual storage valet.
That's a good way to put it. And a lot of modern disk arrays, they have virtualization built in, although it's often vendor specific.
Okay.
But the ultimate goal is to be able to take all your disk arrays, even from different vendors, and manage them as a single unified storage system.
So it's about simplifying things, making everything easier to manage.
Exactly. And at Stonefly, that's something we've been working on for, since we started over 2 decades ago. We've developed sophisticated storage virtualization capabilities for our solutions, all to make things simpler for our customers.
Okay.
You can learn more about it at stonefly.com or reach out to us at sales@stonefly.com.
This has been a really in-depth look at SANs. So to wrap things up, what are the key takeaways you want our listeners to remember?
Well, the most important thing is that a SAN is a dedicated, high-performance network built for storage. It's all about speed, efficiency, and reliability. And it has significant advantages over traditional storage architectures like DAS and NAS, especially when you need high bandwidth and low latency.
Right, and it's amazing to think about all that data flowing behind the scenes, powering so many of the things we use every day.
Absolutely. And as the amount of data keeps growing and as the need for fast, reliable access becomes even more critical, it'll be interesting to see how SANs continue to evolve. What new challenges will we face? What new innovations will we see?
Yeah, lots of questions to ponder. For anyone who's dealing with, serious storage challenges, or if you're just curious about cutting-edge SAN solutions backed by decades of experience, check out stonefly.com or reach out to their team at sales@stonefly.com. They've been pioneers in the SAN world for over 2 decades, and they know their stuff. Thanks for listening to this deep dive into SANs.
Thanks for having me.